Hello everyone, welcome to Reactify Labs. Today we will learn about Amazon S3. So what is S3? Why do we need S3? S3 is basically an object storage. That's it. Nothing more than that. If you understand what this is, then that's fine. If not, then let's understand it. So object storage means it stores objects like images, videos, music, etc, etc, a lot of things. Okay, so this is basically a specialized storage whose only job is to store objects. For example, let's say when you click on some URL, let's say a URL which redirects you on Instagram. Okay, I am not saying Instagram uses S3, but assuming this is how it works, it may be using S3 or some other similar thing. So you click on URL and it redirects you to some video. So the URL is stored in some database, right? But this video is not stored in the database. This video is stored in some object storage, maybe S3 or Google Cloud Storage or Oracle, anything. So this, as soon as you click on this URL, it redirects you to S3 from where the video is played. Similarly, when you store your images on Instagram, again, the images go to S3. Only the URL or small thumbnail is visible to you. And when you click on that thumbnail, then it fetches from that storage and displays it to you. So this is the use of S3. So just storing objects, nothing else. Okay. So I hope this gives you a good starting point to understand S3 in technicalities. Okay. So yeah, let's start. We will follow the following format today. We will first talk about the introduction of S3. Then we will talk about the components, then architecture, then the operations. Next, we will move to talk about advantages, then challenges, then use cases, and then we will see what are the other similar systems or similar system alternatives of S3. Okay. So let's start with this introduction. Amazon S3 is a highly durable and available object storage service that allows users to store and retrieve any amount of data at any time. Okay, so it's a highly durable and available object storage service. Object storage service that allows users to store and retrieve any amount of data at any time. It is designed to provide 11 nines durability. What is 11 nines? It's 99.9 times 9. 4, 5, 6, 7, 8, 9. So total 11 nines. Okay. But it does so by automatically creating and storing copies of all uploaded data across multiple systems. So basically this is percentage. Okay. So it's durable, like it will have very limited data loss, maybe some 0.00000078, this much. This much data loss may be there in the S3. So it is highly durable, right? It means very reliable system. So how does it do that? By automatically creating and storing copies of all uploaded data across multiple systems. So if there are multiple copies, it means that there is no single point of failure. So the data will never be lost. S3 is ideal for storing large amounts of unstructured data such as photos, videos, backups, and big data analytics. So in short, Amazon S3, basically yes, actually S3 means, S3 is a short form of simple storage service. Simple storage service. So 3S, that's why S3. Okay. So Amazon S3 is a scalable, high-speed, web-based cloud storage service designed to store and retrieve any amount of data from anywhere on the web. It's a foundational service in the AWS ecosystem, which offers a reliable and secure object storage solution with a broad range of features. Okay. Next, let's talk about the concepts of S3. So first thing is buckets. Next is objects. Next is versioning and storage classes. So what are buckets? A bucket is a container for objects stored in Amazon S3. Each bucket is unique within a region and acts as the top level directory that holds all objects and metadata. Each bucket name must be globally unique and comply with DNS naming conventions. Buckets are created in specific AWS regions, which can affect data latency and redundancy options. Users can set permissions at the bucket level, controlling who can access the data within. So for example, if you create a bucket named, let's say, my website backups, all the objects stored within that bucket would be accessible under this name. Okay. Next is objects. So objects are the fundamental entities stored in S3, like photos, videos, etc. Okay. It comprises of data and the associated metadata. Objects can range in size from anywhere from 0 bytes to 5 terabytes. Each object can have associated metadata such as content type, last modified date, and custom metadata defined by the user. Each object is identified within a bucket by a unique key, which is the object name, making it easy to recognize, organize, and retrieve. So for example, an image file named photo.jpg stored in bucket my website backups would have a key like, let's say, image/photo.jpg. Let's say, as I said, the bucket name may be my website backups or my web. Let's say this is the bucket name. Okay. Maybe the photo that you added, it had the name photo.jpg. So it's an image, right? So it will be stored in images directory and photo.jpg. Just like the directory system. Okay. Next is versioning. S3 allows users to keep multiple versions of an object in the same bucket, enabling recovery from accidental overwrites or deletions. Each version of an object is assigned a unique version ID. Users can recover and restore previous versions of an object if needed. Versioning can increase storage costs as all versions are retained unless explicitly deleted, so it will consume more memory. So for example, if a user uploads a new version of photo.jpg, S3 will retain both the original and the new version, each with a unique version ID. And next, storage classes. So S3 offers different storage classes that allow users to optimize costs based on how frequently data is accessed and its durability requirements. So there are different storage classes. First is S3 standard. So this one is for frequently accessed data with high durability and availability. Next is S3 intelligent tiering. It automatically moves data between two access tiers when access patterns change. Then S3 standard IA. It is for infrequently accessed data with the same high durability but lower availability and retrieval costs. Then there is S3 one zone IA. It is again for infrequently accessed data but stored in single availability zone. It has less redundancy. Next is S3 Glacier. It is for long-term archival storage with retrieval times from minutes to hours. And S3 Glacier Deep Archive. So it is for the lowest cost archival storage with retrieval times up to 12 hours. Okay. So for example, a company might store frequently accessed web assets like images in S3 standard because standard is fastest, right? While older, less frequently accessed data might be moved to S3 Glacier because if the data is older, it's highly likely that it might not be accessed anytime soon. So yeah. Next, let's talk about the architecture. Sorry. Architecture. AWS has a global infrastructure. S3, sorry, did I say AWS? No, Amazon S3, AWS S3 actually. It has a global infrastructure. S3 is built on AWS's global infrastructure, providing high availability and redundancy across multiple geographic regions. Data can be stored in specific AWS regions, ensuring compliance with local regulations and optimizing latency. And data is automatically replicated across multiple availability zones within a region to ensure durability. For example, a user can choose to store data in, let's say, a region called US West 2 to ensure low latency for users on the west coast of United States. Okay. Next is data consistency. S3 provides strong read after write consistency for puts of new objects in your S3 bucket and eventual consistency for overwrite puts and deletes. Means if there is a first time write, if it's a successful write, then new objects are immediately available for read operations. It means strong consistency, immediate availability. But if there are updates and deletions, it might take a little time for the changes to propagate across all the replicas. So here it follows eventual consistency. If you upload a new image, again as an example, if you upload a new image, it is available immediately for access. But if you overwrite or delete an existing image, it may take a couple of minutes or maybe some time. I cannot exactly quantify it. It may take some time before all the copies reflect this change. Okay. Next, let's talk about the operations. First is data uploading. Users can upload data to S3 through various methods, including AWS Management Console, AWS CLI, SDKs, and REST API. For large files, S3 supports multi-part uploads, which allows users to upload parts of a file in parallel to reduce upload time and improve reliability. For example, a user uploading a 2 GB video file to S3 might use the multi-part upload feature to split the file into multiple parts and upload them concurrently and then reassemble them in S3 later. Okay. Next is data retrieval. Data stored in S3 can be retrieved via direct download, API requests, or integrated services like AWS Lambda and AWS Data Pipeline. S3 supports range get operations, allowing users to retrieve specific parts of an object. For example, a video streaming service might use S3's range get to retrieve only the portion of a video needed for the playback, thus optimizing bandwidth usage. Next is data management. Users can define lifecycle policies to automatically transition objects between storage classes, expire them after a certain period, or delete them after a specific date. Cross-region replication can be configured to replicate objects automatically to a different region for disaster recovery or compliance reasons. For example, a business might set up a lifecycle policy to move objects to S3 Glacier after 90 days and delete them after 365 days to optimize storage costs. So, if you see, if it's new, it may be in standard, then after 90 days, it may be moved to one of these glacier tiers, and after 365 days, the data can be deleted. So, it's the life cycle of the data which is defined, okay, which you can define actually. Next is access control. Bucket policies allow users to manage access to their S3 resources at the bucket level using IAM policies. IAM is identity and access management policies, ACLs, which is access control lists, and CORS. CORS is cross origin resource sharing configurations. So, what did I say? Bucket policies allow users to manage access to their S3 resources. So, if you have a resource in S3, maybe let's say some image. So, who all can access it? So, it can be configured by different things: IAM, CORS, and ACLs. So, ACL. So, IAM is identity and access management, CORS is cross origin resource sharing, and ACL is access control lists. So, I'm not going to talk into much detail about this because this playlist is not for that. Maybe I will create a separate playlist for these. Let me know in comments if I should make one on these or not. Otherwise, I am not going to talk about this because it's not in the domain of this playlist. Okay. So, moving forward, S3 supports both server-side encryption and client-side encryption to protect data at rest and in transit. For example, a healthcare provider might use S3 bucket policies to restrict access to sensitive medical records of patients, ensuring that only authorized personnel, maybe doctors or nurses, only they can access the data. Okay. Now, what are the advantages of using S3? First is scalability. S3 can scale to handle any amount of data from a few kilobytes to petabytes without requiring users to manage infrastructure. Next is durability and availability. S3 design ensures 11 nines durability. I explained before what is 11 nines. So S3 design ensures 11 nines durability and high availability across multiple availability zones. Next is cost effectiveness. S3's tiered storage classes allow users to optimize costs based on access patterns and data retention needs. Next is security. S3 offers robust security features including encryption, access control, and audit logs, ensuring data is protected against unauthorized access. And next is integration. S3 integrates seamlessly with other AWS services like Lambda, EC2, CloudFront, and more, making it a versatile component in cloud-based architectures. What are the challenges now? First is complexity. Because the system is very sophisticated, it has to be complex. Managing a large number of buckets, objects, and policies can become complex, especially as the data scales. Next, performance variability. While S3 is designed for high availability, performance can vary depending on factors like data size, access patterns, and network conditions. Next is latency. Data retrieval times, especially from archival storage classes like Glacier, can introduce latency. You saw before that for these Glacier, it may be a few hours, few minutes to few hours, and for this, at least 12 hours, right? And next is costs. Although S3 is cost effective, storage costs can accumulate quickly, especially when using features like CORS or keeping multiple object versions. Okay. Next, we will see what was that? Challenges, use cases. Okay. So now we will see what are the use cases of S3. So first one is Netflix. Netflix is, it's a platform where you can watch movies and TV shows. They need a place to store all their videos and make sure people can watch them quickly and easily. So Netflix uses Amazon S3 to store all of its movies and shows. When you click on a movie to watch, it streams directly from S3. S3 handles the massive amount of data, all the movies. You can assume how much it would be. One movie may be at least of few gigabytes, maybe 10 gigabytes, considering all the resolutions, 4K, 2K, 1080, 720, different resolutions, and 3 hour movie or 8 hour web series, one season, or 20-hour web series, one season. So the data is huge basically. So when you click on a movie to watch, it streams directly from S3. S3 handles those massive amount of data and makes sure they are ready to stream at any time. Okay. Next is Dropbox. Dropbox is a service that lets you save your files online so you can access them from any device, your phone, tablet, or computer. Dropbox stores all your files like the documents, photos, videos in Amazon S3. This ensures that your files are safe, backed up, and can be accessed from anywhere at any point. Next is Pinterest. Pinterest is a social platform where people share and discover images and ideas like recipes, home decor, and fashion. Every time someone pins an image on Pinterest, that image is stored in Amazon S3. With millions of users adding millions of images, Pinterest relies on S3 to keep all those images safe and easily accessible. Next is Airbnb. Airbnb is a platform where people can find and book places to stay, like apartments, houses, or even tree houses. So when hosts upload photos of their properties, those photos are stored in Amazon S3. This way, when someone wants to book a place, they can quickly see all the photos, which load fast because of S3's storage and delivery capabilities. And Spotify. Spotify is, we all know, a music streaming service where you can listen to millions of songs. Spotify uses Amazon S3 to store all of its music files. When you play a song, it streams from S3, ensuring that the music loads quickly and reliably, no matter how many people are listening at the same time. Okay. And at last, we will see what are the alternatives of S3, or what are some of the other object storage services. So first is Google Cloud Storage. Okay. Google Cloud Storage is Google's equivalent to Amazon S3. It provides scalable and secure object storage for various use cases, from data archiving to big data analytics. Like S3, GCS offers different storage classes such as standard, nearline, cold line, and archive, each optimized for different access patterns and costs. GCS is globally distributed, making it ideal for applications that need low latency access to data across different regions. GCS works well with other Google Cloud services like BigQuery, Compute Engine, and Kubernetes Engine. Use case example would be Snapchat, which uses Google Cloud Storage to store massive amounts of multimedia data, allowing users to access their photos and videos quickly. Next is Microsoft Azure Blob Storage. Azure Blob Storage is Microsoft's cloud storage solution, cloud object storage solution actually, which is similar to S3, designed to store massive amounts of unstructured data. Azure offers hot, cool, and archive tiers, each optimized for different levels of access frequency and cost. Azure provides various redundancy options to ensure data availability and durability across regions. Azure Blob Storage integrates with other Azure services, making it a critical component of Microsoft's cloud ecosystem. Use case example would be Xbox Live, which uses Azure Blob Storage to store game data and user profiles, thus providing fast access to millions of players worldwide. Okay, next is IBM Cloud Object Storage. IBM Cloud Object Storage is IBM's scalable storage solution, which is again similar to S3 and designed for handling large volumes of unstructured data. IBM offers multiple storage classes to optimize costs, including standard, vault, and cold vault. It provides built-in encryption and identity management features to ensure data security. And like other cloud providers, IBM Cloud Object Storage offers data centers around the world for low latency access. For example, NASA's Earth Science Data and Information System uses IBM Cloud Object Storage to store and manage petabytes of Earth observation data. Next is Oracle Cloud Object Storage. Oracle Cloud Object Storage is Oracle's answer to S3, which provides secure and scalable storage for enterprises. Oracle offers high durability through automatic data replication across multiple storage needs. It is designed to work seamlessly with Oracle's databases, analytics tools, and other cloud services. It offers tiered storage to manage costs based on access frequency. Large financial institutions use Oracle Cloud Object Storage to store sensitive financial records and backup data. So, yeah, these are some of the alternatives to S3. So, whatever you learned in S3, you can assume safely that it will be more or less similar in the other this object storage engines. Unless you have to work on this, you don't explicitly need to go and memorize all the things about all the other storage engines. Okay. So yeah, I hope this video gives you a good idea of S3, where it is used, why it is used. So let's say tomorrow somebody asks you to draw a system like Facebook, and then you write that, okay, if I upload something on Facebook, it goes to the database. Then you won't make this mistake. You will say that the URL will go to the database and actual object will go to the object storage, maybe S3, or you can use any other name. Okay. So yeah, that's all there was in this video. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.